Awesome, and we can go ahead and get started. So continue to introduce yourselves in the questions and chat pod. Feel free to let me know if you can hear me as well. Someone can reply just yes in the chat pod, that'd be great. Awesome, you can hear me. Great, so we can go ahead and switch to our presentation that we'll be having today, and I can start with some moderator notes introducing some of our speakers today and what we'll be discussing. Awesome, and again, thank you everyone for joining us today. We're going to bring it up from the top of the presentation in a few minutes. Awesome. So, welcome everyone to this installment of our CARMA webinar series. We've done a few webinars in the past, and we'll continue to do some webinars, and you'll hear more about that later on. So today our webinar is going to be covering the CARMA Cloud and CARMA Streets two products in the CARMA program. My name is Monica Brito, and I'm a communications professional here with Leidos. I'll be your moderator today. As a disclaimer, we will have both FHWA personnel and as well as FHWA contractors, including myself, speaking today, and I'll introduce them shortly as well. If you want to be part of the conversation during our Q&A portion that's going to be held at the end of the webinar, we have some dial-in information here on this slide. You'll see the phone number you can dial in, the room number, as well as how to mute yourself and unmute yourself. We currently have all the participants muted just to allow speakers to speak. But if you have any questions throughout the webinar, feel free to put them in the questions and discussions pod, and we can see if we can address them at that time or hold them to the questions portion of the webinar. On the screen, you're going to see the chat pod, and we'll also be having some useful links that will be available to you. We will bring those up shortly, but in those useful links, you'll see two really important pieces, one being the CARMA Collaborative Contribution Form, and I can link that shortly in the chat pod as well. The CARMA Collaborative Contribution Form, if you're interested in joining the growing community of CARMA users and stakeholders, please fill out that form. That's how you'll be updated on any CARMA product development, any software updates, as well as information about the CARMA Collaborative itself. And that's how you'll find out about some of our webinars coming up. We also have the CARMA Cloud GitHub link there. You'll learn today CARMA Cloud is our latest product in the CARMA program that is available for download on GitHub. So that open source code is available on GitHub, and we'll have the link in the chat pod as well. And that's available at this time for download. And we'll learn more about CARMA Streets as well, which is on our CARMA GitHub as well, but will be available for download at a later time. With that, I'd like to introduce you guys to our speakers today, and then we'll go over our agenda. So we have Taylor Lockerain from Federal Highway Administration. He is the CARMA Program Manager at FHWA. He oversees the Cooperative Automation Research Program in the Office of Operations Research and Development at Turner Fairbank Highway Research Center. He's leading our team of engineers developing the CARMA platform, supporting the testing and evaluation of cooperative driving automation. We have Kyle Garrett with Synesys. He's a founding principal with Synesys Partners, over 40 years of system engineering and project management experience. Kyle and Synesys Partners, they're providing our infrastructure systems analysis and data modeling for the CARMA Cloud project, and you'll be hearing more information about CARMA Cloud and how you can get involved and download that open source software today. We have Wade Goforth with Leidos, and he will be explaining CARMA Streets. So he's a system engineer with over 12 years of experience in engineering, project planning, management, design, and execution. He's playing a key role in the development of CARMA Streets, and we'll be able to provide a great overview of that today. With that, we have our agenda. We'll be going over a cooperative driving automation and CARMA review. We'll look at CARMA Cloud within the program ecosystem, CARMA Streets within the program ecosystem, what's next in CARMA program, and the questions and answers portion of the discussion. And with that, we'll start with some poll questions. So we'll bring up two questions just to get a gauge of who's here with us today. Again, feel free to continue to introduce yourself in the chat pod. Awesome. So first question, you guys are really quick. So what is your affiliation? We'd like to see who's here with us today and get a gauge. Awesome, we'll give that another few seconds there. Awesome, I believe we're seeing most of our audience being from the academic world. We have a lot of private agency as well, federal government, of course. And seeing some others. Feel free to explain the other and where you're from if you're in the chat pod as well, once we get back there. Awesome, and we'll go to the second question. So, what is your level of exposure to CARMA or cooperative driving automation prior to this webinar? That was a very quick, very familiar, so that's great. Awesome, so we're seeing actually a pretty even cut between very familiar, somewhat familiar, and not familiars. So for those of you who are not too familiar with CARMA, we'll give a brief overview of CARMA and the cooperative driving automation shortly after this poll question. And we'll be reviewing, for those who are somewhat familiar and very familiar, some of the updates being CARMA Cloud and CARMA Streets. Awesome, good to see some somewhat familiars, lots of somewhat familiars. Awesome, and with that, I will be passing this on to Taylor Loughlin, our CARMA Program Manager, and he'll be overviewing the cooperative driving automation. And be on the lookout for some links in the questions and discussions pod as well for the CARMA collaboration, a contribution form.
Monica, thank you so much for kicking this off. Very great to see all the responses in the poll questions. Sounds like we have a very diverse group today with folks that are familiar, somewhat familiar, and some new folks that are just want to learn about what cooperative driving automation is. So this is a great slide to really kick this off. You know, CDA, cooperative driving automation, you know, SAE, you know, really focused over the past year working on defining this for the industry, and within the ORAD committee adopted this task to develop a taxonomy, which is what's called the J3216, 3216. And this is a really good document that, you know, really establishes, you know, a way for us to now talk about what this cooperative driving automation technology can do in the system. And so imagine it's about machine-to-machine sharing of information. So imagine if the transportation users could start talking to each other, sharing information, what are the opportunities we can start to see and capabilities we can start to see and efficiencies and safety. So very excited time and a very you know, exciting past couple of weeks as SAE has decided that they now offer this new standard document at no cost. They see a lot of value in providing this this taxonomy, this JDoc to the community so that we can start talking about this in the same terms and really thinking about where does this technology moving in the future. So pretty excited about SAE's decision to make this a document available to the public. And within the document, there is a table that really, I think, opens the door between the relationship between, you know, connectivity and automation. And they do this by looking at this table where they take the automated vehicle levels from J3016, levels 0 through 5, and they brought together this relationship about the classes A through D. So pretty exciting opportunity here to read that document. I highly encourage you guys to go download it today and start looking over it. You know, the classes A through D are what we're focusing on within cooperative driving automation to understand where this technology can provide benefits to the system with all this emerging automated vehicle technology. So very exciting. And so when you talk about DOT and Federal Highway, what is the CARMA program doing? Well, it's our initiative that we're trying to focus on, you know, what this technology means to the system and how can we see benefits in moving people and goods across the country. So as emerging automated vehicle technologies is being tested on public roads and closed test tracks and really, you know, moving as fast as light, you know, to get that system driving safely, you know, and with the V2X program, you know, and adding that connectivity to the system, you know, that's what our program is really looking at. How do we see this interaction between automated driving technology and V2X communications to really leverage some of that opportunities in system management for the transportation system as a whole. And so by doing that, we establish what's called the CARMA ecosystem. We've had a couple webinars in the past to kind of explain that, but I think today what's exciting is we're going to talk about CARMA Cloud and CARMA Streets. And to me, I think this is a very important time to talk about these two products, because when we look at cloud and what cloud can provide as how we, the rules and how we can manage the system, and getting that software code out to you all to be able to use it with us and to understand what this could mean, is I think it's an extraordinary time. So we're very excited to have Kyle Garrett here with us today to kind of go through CARMA Cloud and CARMA Streets, a new initiative we're kicking off. And Wade's going to really blow your mind today with how cool this concept is, what it really means to the system, within cooperative driving automation. Of course, we have our evaluation tools. I'll give you guys an update later on about where we stand on a couple of those activities, as well as our collaboration. We're going to continue to collaborate and support you as you start to merge and dive into this new emerging area. So just to highlight, the CARMA ecosystem today, we've established 3 research tracks: traffic, reliability, and freight. And being a multimodal program, we're trying to focus our resources and our time in these 3 areas to really focus on how this technology can support us in reoccurring congestion, non-recurring congestion, as well as CMV and port use cases. So we'll be talking a little bit about the port use cases later on in the presentation as well. So very excited about today's presentation by our experts, and I hope you all enjoy the conversation, and feel free to put questions in the chat pod. We'd love to hear from you. So with that, we'll pass it over to Kyle Garrett.
Thanks so much, Taylor, for the introduction and for the excitement. It is a cool time to be involved in CARMA. We've been working on CARMA Cloud for quite some time, but I think this is maybe one of the first times we're really pulling back the curtain, and appropriately so, because as Taylor said, CARMA Cloud and its source code are now available on GitHub, and there are links provided for you to go take a look at what's out there. My job today is to give you a very high and fast overview of how it came to be, the thought process that went into it, and maybe just a little bit about how it could work for you. So I want to start here by drawing your attention down to the graphic in the lower right. When we talk about the CARMA platform, we're primarily talking about, of course, the vehicles and what's on the vehicles. But vehicles operate on roadways, as we all know. They operate according to sets of rules, and they have to navigate around the incidents and events and weather that come their way. So CARMA Cloud really came about because we had to have a way of providing to CARMA platform all of the information that it might need and might not be able to get from its own sensors about the operations intent for the roadway network. Meaning things like, well, how is a CARMA platform vehicle, an AV, going to know what a work zone looks like? How is it going to know that there may be an emergency vehicle approaching when it can't yet see it, can't yet detect it with its sensors, and maybe for that matter doesn't have a direct vehicle-to-vehicle communication with it? So from there we then ask ourselves, well, what kinds of information do we really need to get? We know that we're on a roadway. We have to provide some information about what that roadway looks like, a map. But really what we fell to quickly was that we had to provide information about traffic controls or traffic control messages. Things that could, for example, change speed limits, or at least inform of what the local speed limits are. Perhaps manage headway between vehicles to say, you need to keep this minimum gap in this location for whatever reason. Especially for commercial vehicles, we looked at platoon size. Is there a limit from an operational perspective that the agency that's in charge of this set of roadways wants to apply to this particular location? Where are lane closures? Maybe there are weather events. Maybe there's flooding that we want to provide. There may even be lane restrictions by vehicle class, potential by occupancy, and time of day, and of course a whole host of other things. So what CARMA Cloud does for us then is, number one, provides a model that you can get off GitHub for these operational support services through the CARMA Streets that you're going to hear about and the V2I hub that's attached to that. It enables communication not just with the other things that are in the cloud on the infrastructure side, but with vehicles, users, etc. And it really does that by defining everything down to a set of geofences and lane segments to which we want to apply those TISMO strategies. And then it applies them both generally but very specifically for ADS and the rules of practice that go with it. So once we got down that path or had a model for what we wanted to do, we started looking at what other resources were going to be available within the CARMA ecosystem to work with. You know, at the time we started, we had V2I Hub, and are excited now that we have Streets and an even more dedicated set of services to help us navigate the roadside. On the cloud side, we've added some analytics. Of course, we've always been attached to the traffic management services, say in an ATMS or a TMC, and the weather and work zone and incident data that go with that. I also want to call out very specifically that from the get-go, we have been excited about the kind of data that we can get from a system like the Work Zone Data Exchange, where we're already working to collect information from the infrastructure owner-operators as to what kinds of work zones are going to be out there and what they look like. Perhaps this is better Taylor's point, but there are grants available to assist in that process. I want to take you down into a little bit of our thinking now, or I should say our rethinking. Since we had the luxury of starting with pretty much a clean slate, we really had to ask some hard questions about, honestly, what is a roadway? How does an automated vehicle interact with that roadway? And we ended up deconstructing a lot of what we thought we might already know. So we identified a set of system objects and then a set of a model that lays over on top of that, and even some data standards to go with it. Typically, when we think about maps, when we think about the roadway system, we think of them as being very flat in that it's a road, it's on a map, it makes sense. But we really wanted to distinguish here between the landforms themselves and the geophysical models that go with that, and the very traditional maps that go with that, and then start to strip off so that we could manage them more explicitly, things like, well, where are the roads on those landforms? Where are the bridges? Are there other pieces of roadway furniture that we need to track? There's some infrastructure data that goes with that. And a lot of our thinking here was informed really by trying to make sense of the HD maps that we were getting and that we would end up using in the CARMA Cloud demonstration. But we also then thought back to the Green Book itself and how roadways are designed and how we needed to reflect that in the CARMA Cloud models. On top of that, we have a layer of traffic controls, which are part of the roadway to the extent that they're deployed there, but they're also somewhat independent of that. We like to think that the stripes and the signage are always in very specific locations relative to the pavement, but it doesn't always work out that way. And if you've driven through a work zone recently, you know that those pavement markings can be changed pretty dynamically too. So we think there's a control layer that's informed by the manual and uniform traffic control devices very specifically, but who knows in the future. And then we have operational layers above that for road weather, for traffic, and for events, and we have standards that go with each one of those. What this does, by deconstructing what we think we know about the roadway or the road environment on which the AVs are operating, we were able to go back and really have a common set of system objects that both human and automated drivers would be reacting to in equivalent ways. Then we are able to rebuild the maps by overlaying any of those layers that we needed for a particular management or TISMO problem. We had data standards already in place for almost all of these things, and we wanted to make sure that those remained common. I have not heard anybody yet suggest that we're going to end up having two MUTCDs, one for AVs and one for human drivers. That really doesn't make any sense since they're going to be occupying the same physical infrastructure and doing the same kinds of driving tasks for the foreseeable future. So we need to make sure that we use common data standards The roadway controls, markings, and signage, we separated them, but again, they have to be integrated back in to give a complete picture to an AV or to a human driver. One of the subtleties that we found, though, was that by separating them out, we were able to come up with very, very dynamic traffic control cases, such that we literally could be changing the traffic control model for a work zone as somebody deployed at the site was moving traffic cones, for example, assuming that the data associated with those cones was also being sent back to CARMA Cloud so that we could manage and coordinate the mapping and its publication. And then, of course, we have incident work zone cases, and we have essentially taken a work zone and, again, rebuilt it from the bottom up. Recognize that a work zone, as the MUTCD describes for us, is really a set of traffic controls. And then we bundle those back into a work zone. Or if it's an incident, it's a set of diversions and it's a set of traffic controls that are deployed on site by personnel. If we can get the data that we need from those, then we can dynamically reconstruct what an incident actually looks like from those data sets. In practice, we can do something like this. This is an overhead view in our CARMA Cloud tool for looking at the lane constructions and the control zones, or control messages really, that we've applied to this infrastructure. So you probably can't see my mouse, I don't think, but in the upper left we have one intersection, the upper right another, and all of the white markings on there are actually showing you the control lanes or lane controls as they flow through the intersections. In the lower center of the diagram next to the parking lot, and then it zoomed in on the right-hand side, you see a work zone that has had new traffic control messages sent out and applied such that we can route traffic around that work zone area, in this case in two directions rather, by controlling, as is shown by the stop line there, access to that single lane that remains. So I want to now go through and go yet even a little deeper and talk about how this actually works in practice. So on the left-hand side are some notes. On the right-hand side, an activity diagram, sequence diagram that is intended to show the flow of information from the vehicle to the platform, to the hub, to the cloud, and back again. So our presumption is that we, as an automated vehicle starts its route, it's going to request traffic control messages for the route that it intends to take. And it then sends a traffic control request that's really just a boundary for, here's the route I'm going to be on. It can be as general or as specific as the vehicle is able to provide that information at that time. So once we set those boundaries as tightly as we need, we can have that information sent from the platform through the V2X hub back out to the cloud. And it's worth pointing out here that because of the way these messages are constructed, we can adjust for message size, for example, if we need to do so for transmission purposes across between any of these nodes on the network. And it's also asynchronous in the sense that if a request goes out, it can be partially fulfilled, and the messages themselves carry enough content that we can keep track of whether the entire request has been fulfilled or not. So if you're coming in and out of coverage, it's okay. You're going to get it the next time you come back into coverage. So to finish this set of transactions then, once that is received by CARMA Cloud, it constructs a set of traffic control messages filtered by the boundary that's been given for the route that's being requested. And we send a whole set of these. They're per unique traffic control type or vehicle type, so we could have controls that apply, for example, very specifically to oversized or overweight vehicles, or that apply to motorcycles. We can talk about lane restrictions. We can talk about all of the very particular traffic control types that need to be applied at very specific locations. So each one of these traffic control messages will contain a type. Is it a a right lane control. In other words, can I pass over the right side of this lane? Can I pass over the left side? Do I have to stop at the end of this particular lane segment? How much space do I have to keep between the vehicles that are, between myself and the vehicles that are in front of me? It has all of the path geometry definitions that go with that. Am I of the right type of vehicle that this control applies, for example? And then, of course, schedules to go with all of those. So it might be a schedule for a work zone that we are sending out hours ahead of that particular work zone implementation, and we would expect then that CARMA platform is going to keep track of that and know that when I return on this path, it's going to look different. So all of those control messages are sent to CARMA platform. As the vehicle follows its route, it can get updates, and in fact, it can request those updates as often as it wants. If there aren't any, we'll send back a message that says, nope, no updates for you. And that process repeats until the route is completed and the vehicle has arrived at its destination. The path geometry, one last little detail here, includes all of those things that you might expect to see in a map, but again, it's based on the path, not necessarily based on the pavement. That's my really, really quick overview of what's in CARMA Cloud. I see that there are questions popping up in the chat pod, and we'll probably get to those later on. And in the meantime, I'm going to pass it back to Monica, who I think has some poll questions for us.
Yes, so we will bring up the next poll question. These are going to be some short answers. How does CARMA Cloud apply to your research based on what we talked about today? Are there any additional needs as a stakeholder that are pertinent to CARMA Cloud? So feel free to type in the chat, in the type answer pod, sorry. So how would you see CARMA Cloud applying to your research? We'll give it a few seconds for people to submit their answers. All right, so the requirements will affect the data that we need to provide to OEM. Oh, this is great feedback. The support for future development. CARMA Cloud can be used in my research for increasing work zone safety. How CARMA can be integrated with the infrastructure. It is very relevant and in line with some of my plans for future research. I started developing a classification for traffic control. Great if you submitted that answer. I provided some links in the chat pod that if you want to get connected with our team so that we can start working together, that would be awesome too. Let me see, I have some good answers coming here. We are considering a larger scale deployment for mixed traffic. Improving safety and operation of mixed environment, improve traffic control approaches. For OEMs and ADS developers, improve freeway mobility. Awesome, we'll give it another second and then we'll move to the second question. But if you think of anything else, feel free to use the discussion and chat pod as well. I think we can go ahead and close this one and then we'll move to another question. So based on what we talked about just now, how could CARMA Cloud be improved, and what additional features would you like to see that may be bouncing off of some of the answers that provided before? How can this help you integrate into your research? How can CARMA Cloud be improved? We'll give it a few more minutes, but if you think of anything else as well after this poll question, feel free to type it in the chat pod. I haven't heard about security issues related to CARMA Cloud. Maybe that's a question that we can address later on during the questions portion of the webinar. But if you have questions, if you want more information about CARMA Cloud so you can see how additional features could help your research, definitely feel free to email our team at karma@dot.gov, and I'll include that link as well in the chat pod. Okay, CARMA should support public infrastructure network nodes to accelerate the deployment of connected and autonomous systems, centralized control versus individualization. How is it reliable for safety? Awesome, this is some good feedback that we definitely will consider. I think just for the purposes of moving along, we can end this poll question, and we will continue along. So I'm going to actually pass this over. Poll questions here. We'll pass this over to Wade, who's going to give us our introduction and really your first look at CARMA Streets. Wade, take it away.
Thanks, Monica. And like you said, I am going to introduce CARMA Streets. And CARMA Streets really grew out of the need to have a system in the domain between the vehicle and the TNC level domain that Kyle described. There are numerous interactions where vehicles and infrastructure components need the ability to rapidly communicate and change their plans, change their trajectories. And so CARMA Streets came about as a platform that is intended to be installed at the edge as opposed to being installed at the cloud, and be able to communicate with vehicles and with infrastructure components in order to optimize throughput and improve safety in a number of smaller scale traffic situations where CARMA Cloud would not be able to provide enough information at a high enough frequency. So it provides a local interface between management applications like CARMA Cloud and roadside infrastructure from a configuration standpoint, but it also has the ability for roadside infrastructure systems to communicate with CDA vehicles and each other. For example, a number of intersections in sequence acting as a corridor to optimize the throughput of vehicles. And then, like I said, it has edge computing capabilities for process optimization, and I'm going to talk about a few examples of those that we have started to work on. So one of those is TISMO. That's excuse me, Transportation System Management and Operations. Forgot what it was for a second. And the objectives of the project that we're working on now, which is a number of intersection approaches and intersection styles, is to maintain safety through intersections, reduce traffic congestion, and to improve energy efficiency. Now, if you look at the graphic that's on the slide, it gives you kind of a high-level overview of this. This is an unsignalized four-way stop intersection. You can see the shaded area is the communication radius, that is the radius in which vehicles can communicate with each other and with the roadside equipment at the intersection. And you see a number of different vehicle states here representing vehicles that are approaching the intersection, vehicles that are ready to pass through the intersection, vehicles that are actually in the intersection, and vehicles that are leaving the intersection. So I'll dive into this example a little bit further and talk about the first objective, maintaining safety, and that can be done through communication. So you see on this slide that there's a central computer involved in coordinating traffic amongst RSUs and amongst vehicles, and that central computer in this example is CARMA Streets. And so CARMA Streets has the ability to consume all of the messages that are being broadcast by cooperative vehicles as they approach and pass through and depart the intersection, and optimize, order, and provide them trajectories to reduce their energy consumption. And there are different classes of cooperation where a piece of equipment like CARMA Streets can provide advantages. Taylor mentioned the four different classes of cooperation for CDA vehicles, and you can see the implications of that in the graphics to the right side of the slide, where ordinarily at an intersection, if they're human-driven or they're very low-level cooperative vehicles, you're limited to just having one vehicle in the intersection because you don't know what the other vehicles are going to do. You don't know how much space is able to be occupied. But through cooperative driving automation and through having a centralized computer system like CARMA Streets, you can increase throughput through the intersection by knowing the vehicle intents and providing trajectories to each of the vehicles that are ready to depart, which allows turning vehicles to occupy space in the intersection that does not conflict with vehicles that are going straight, and therefore increase safety and throughput through the intersection. As I just said, this is an example of exactly how CARMA Streets can improve throughput through a four-way stop by identifying which vehicles are ready to depart and their intents, which would be Class B cooperation or higher. More vehicles can occupy the intersection and reduce the amount of time that any individual spends stopped at that particular intersection. And the result of that is improved energy efficiency. So by knowing vehicle statuses and intents, a platform like CARMA Streets or an infrastructure application can reduce or change the trajectory of a vehicle, prescribe a trajectory to the vehicle that reduces the amount of energy required to get to the stop location if there are several vehicles in front of the particular ego vehicle that are going to occupy the intersection prior to the ego vehicle getting there. So in an ordinary situation with a human driver or lower levels of cooperation, you typically see an approach pattern like this one on the left side of the graph, where that's the maximum rate of deceleration for the vehicle, and you simply end up with wasted energy and wasted time. But by knowing the intents of all of the vehicles and optimizing a trajectory for the entire group of vehicles, you can create an optimized speed profile that limits the amount of time that the vehicle spends stopped at the intersection. And what this looks like from a system perspective is you have two or more vehicles approaching an intersection. They have the ability to communicate with each other and with a roadside unit or roadside equipment that CARMA Streets would be connected to. And CARMA Streets is employing V2X Hub as a protocol translator, which you may be familiar with. V2X Hub is another one of our research platforms that handles message distribution and protocol translation. And it uses V2X Hub to obtain the information about the vehicle statuses. Now, in lower levels of cooperation, like I mentioned, vehicle status is ostensibly all that you would get from an individual vehicle, but as the cooperation classes increase, you would also get vehicle intents. For example, I'm going to enter the intersection on this lane ID and exit on another lane ID, which provides CARMA Streets information as to what options it has available to optimize the vehicle traffic, and it returns a vehicle entry plan to all of the vehicles in the intersection by way of a roadside unit, and that's how vehicles know what their target time to enter the intersection is, and it allows them to plan their trajectories appropriately to maintain safety. And that applies to cooperation classes C and D, where in cooperation class C, vehicles still have the ability to determine their own trajectories and plans if they have a disagreement with the infrastructure. And in Class D, it becomes prescriptive, and the infrastructure system is actually providing the trajectory and intersection entry plans to the vehicles as they approach the intersection. Now, to expand this a little bit, you can add in a traffic signal. So in a signalized intersection, vehicles don't have to stop as long as they have a green signal. And so you can optimize traffic throughput further by utilizing the signal phase and timing message, which is in the J2735 specification, and providing that signal information to the whole group of vehicles approaching the intersection. And the speed profiles that you get as a result of that look like this. And this shows vehicles as they approach an intersection in waves with their speed profiles adjusted based off of the signal phase and timing information that is provided through CARMA Streets. And CARMA Streets helps optimize these speed profiles by ordering the vehicles as they go through the intersection, so they're not arguing with each other about who's going to go through the intersection first. And so what you get is an improvement in energy efficiency across all of the vehicles going through the intersection. And what that looks like from a system perspective is you see the same configuration of vehicles, roadside units, and CARMA Streets, but you add in a traffic signal controller with signal phase and timing information, and CARMA Streets uses that as an additional piece of information to help optimize the trajectories and the entry plans for all of the vehicles that are approaching the intersections. Now, one objective for the future to really improve safety and throughput is intersection observation systems that employ devices like FLIR cameras or video cameras, ordinary video cameras, to provide indications of objects that are occupying the intersection that perhaps vehicles cannot see. It's often referred to as shared perception, and CARMA Streets can assimilate that information and provide it through the vehicle entry plans to the vehicles that are approaching the intersection so that you get improved safety as well as the increased energy efficiency and coordination that it is already able to provide by synthesizing all of the vehicle information at the same time. And so this is something that we're working towards through this incremental development of the CARMA Streets platform. So I'm going to switch topics a little bit while still on the subject of CARMA Streets and talk about another way that it can be used in another project that we're working on. And this is on the freight track that Taylor had mentioned earlier. And the objective here is to study the idea of having captive trucks that are automatically controlled within a port. And so the demonstration that we're working on is where trucks are manually driven into a staging area that is just outside of a port, and then the trucks are then under automatic control between the staging area and the port area, where containers can be exchanged, containers can be dropped off inside the ports, new containers can be picked up inside the port or taken back to the staging area in order to be taken to their ultimate destinations by human drivers. And our demonstration plan for this employs a virtual staging area that has an entrance and an exit, as well as multiple pickup and drop-off locations where the CMV would be instructed to pick up or drop off a container by CARMA Streets, which the CMV would then do, then approach the port area, receive permission to enter the port by CARMA Streets, drop off the container at a location that's specified by CARMA Streets, and then go through an inspection process where a port inspector has the option of instructing the vehicle to pull into a location for further inspection or then pass through to the exit of the port. And the way that that's done is you see the same CARMA Streets instance here, but there's a different plugin for port drayage management than what you would have for the intersection system. Of course, V2X Hub is still employed here for message translation and communication with roadside units, but you've got a CMV requesting a container transfer from the staging area. This goes through the RSU to CARMA Streets. CARMA Streets interfaces with an intermodal terminal management system, which is responsible for optimizing the container pickups and drop-offs, which responds with the location of the container that the CMV should pick up and the container ID that it's targeting. This then goes back through CARMA Streets, back through the RSU, into the CMV, and it is able to move to its next pickup point, either within the port or within the staging area. Now, another interesting addition to this system is a loading device that would be a crane or a forklift or whatever the nature of the loading device is at the particular port. It can actually employ CARMA Messenger, which Kyle and Taylor mentioned, to communicate with the CMV to know when the CMV is prepared to accept the container or have the container unloaded, because the presumption is that this loading device is going to be controlled by a human. So CARMA Messenger helps fill the gap between a CDA vehicle and a non-CDA vehicle and helps aid the operations at the port. So there's a couple different examples of projects that we're working on utilizing CARMA Streets and why we're using CARMA Streets as opposed to CARMA Cloud to provide that communication between infrastructure systems and CDA vehicles at a local level. So that concludes my portion of the presentation, the introduction to CARMA Streets. I hope that's been helpful. Feel free to ask questions, and Monica is going to provide some more poll questions to you.
Awesome. Thank you, Wade. So we'll go into some poll questions. I think we have poll question number 6 coming up. It's going to be another short answers question. So feel free to type in the little pod. So how does CARMA Streets apply to your research? Are there any additional stakeholder needs that are pertinent to CARMA Streets? Similar to the CARMA Cloud question about CARMA Streets now, so how does it apply to your research? Give it a few seconds for people to type in. We had a good question come in, any use for transit? Feel free to answer. If not, we can talk about it later. Would support research into smart intersections among multiple types of vehicles, something that's relevant. It can be integrated into some of our research ideas. Seems as a middle component between the TMC and the vehicle. Awesome. We'll leave this up for another second, see if any other questions come in. But like I mentioned, I put some links in the chat pod. If you have any questions about how CARMA Streets can apply to your research, feel free to email us or fill out the CARMA Collaborative contribution form. CARMA Streets could provide information on other vehicles which can be used to increase the effectiveness of our schemes, also emergency vehicles. Great, this is some great feedback. I guess we can go ahead and close this poll. If you have any answers that you'd like to submit, feel free to put them in the chat pod soon. Or if you have any questions, we'll handle those in a few minutes. And we'll pull up the next question. So how can CARMA Streets be improved, and what additional features would you like to see added? Again, that's how can CARMA Streets be improved? What additional features could be added? We'll give it a few minutes for people to post their answers. Awesome, I'm seeing here some answers. So have you looked at 5G technologies for communication? The support of heterogeneous wireless communications like a 5G DSRC would be good to know what the smallest systems it could be deployed onto. And features to allow testing for CDA vulnerable road users, communication with drones. Awesome, we'll give it a few more seconds and we'll move to the next poll question. For all CDA systems, focus on strings, protection from So will CARMA Streets be integrated with the CARMA simulator? How can this be expanded to rural? These are some of the great questions we can answer during our questions and answers too. We can go ahead and close this poll and we'll move to the next question. Awesome. So please select the top 2 use cases and application groups for future testing and deployment. So select the top 2 that are most important to you in your research for future testing and deployment. Initially seeing a lot of traffic control using CDA technologies and isolated intersections. Okay, we're seeing a good mix between all of the options. A few more minutes, or a few more seconds to allow those to answer. think people have answered. Awesome. We can go ahead and close this poll. And we will move to our last question. For our last poll question, so please select the top 2 use cases and application groups for future testing and deployment. Just continuation of the previous question. I love seeing how some people change their answers. Awesome, getting some good feedback, interacting with pedestrians and bicyclists, work zones. Awesome, really good to see what the audience is focused on here as far as the top 2 use cases. We have weather events following the top 2. Great. Well, thank you everyone for answering those poll questions. We can go ahead and close this one. And I will actually be passing it back to Taylor, who's going to talk about what's next in the CARMA program, some updates, and just some more general information.
Thank you, Monica. Great presentations, Wade and Kyle. I really think you guys did a great job, explaining, what we've done with cloud and where we're going with streets, and that kind of is the first bullet there. The CARMA Cloud code is available on GitHub today. You can download it. CARMA Streets, as we develop it, we will be releasing the code in the Agile process, through the Agile process into GitHub. All of our Confluence pages are currently being reorganized, so we will be posting out a new structure of Confluence pages that will host all the documentation for all these products, as well as the other products we have within our CARMA program. So those will be coming soon. We have CARMA 1/10 vehicles that I want to talk to you guys a little bit about for Drayage research, and of course our no-cost support. Looking at what we're doing with the 1/10, I think to us this is a very valuable tool in our toolbox. It enables us to kind of scale down the cost of doing this type of testing on a physical device. So of course we're building out a lot of software simulation capabilities, looking at using Carla. I saw a question on Carla, looking at using Sumo and some of these open source modeling tools so that we can model these capabilities of cooperative driving automation that CARMA is developing. But now with 1/10, our goal is to really scale it down. So now you can even use these 1/10 vehicles in developing algorithms that can be very helpful when testing these things out on, let's say, on a university campus. And maybe you want to have a project where you buy 50 of these and you want to see how do you do a cooperative merge during a very congested time, right? And maybe some of them you make cooperative and some of them you make just ADS. And you can start to see how do these vehicles negotiate around other vehicles and how does this cooperative behavior for, Class C type of research really, come about. So there's a lot of opportunities, I think, with CARMA 1/10. And as we start to build out the core software code working with the F1/10 community, we're going to be releasing that on GitHub so that that base code is available. Our goal is to be able to produce the CARMA 1/10 for a passenger vehicle and a heavy truck. That's a 1/10 scale heavy truck, so that will enable us to look at different types of systems and different types of use cases with these vehicles. So keep an eye out. We'll be launching this Confluence page soon that will have more of the documentation for where we're going, and then there's a lot of opportunities to partner with us and help us advance this technology so that it's a valuable tool for you all to use in your program. The multimodal research, especially for Drayage, is really taking off. This past summer, we accepted our trucks from our ADS supplier, and we've added the CARMA platform software to these trucks, so they now are classified as a CADS SAE Level 3 Class A through D truck and platform. So we're pretty excited about that. We have a lot of work right now with FMCSA going through their experiments over the next few months, and then moving into next summer, we'll be conducting that first prototype use case that Wade kind of walked through, the CARMA Streets component of it, where how do we automate the movement of containers in that congestion that gets built up at the ports going from the docks through the processes to the parking lot. So we've got a very exciting project with the Port Drayage, and then follow-on research looking at conducting this experiment at a real port with all 4 trucks. So there's a big, bright future for Port Drayage, a lot of opportunities to really see how this technology can be deployed in some different use cases outside of some of the traditional ones that we're looking at with traffic control. CARMA Collaborative and Support Services, again, these are services that we have provided at no cost. I mean, CARMA Collaborative we built this for you all to engage with us and each other. So it's not just just for us at one-on-ones with you all as leaders in this community, but it's for you all to work together on sharing what each of you are learning to kind of advance the science, right? Advance this technology. So we're very excited about CARMA Collaborative as we start to establish the technical working groups over the next few months. That's going to really start to brand the technical component of what we are trying to pursue with open source development, getting us to work together and share and learn, and that's how we're going to accelerate this technology to market. So very excited about CARMA Collaborative. And support services, this is your service. We put this and we set this up and we built this in partnership with the ITS JPO in trying to help you all get started with this concept. It's very new. It's new software. We're using lots of different tools. The CARMA platform is built up with lots of different software components, different standards, OpenDrive, OpenScenario, OpenCV, AutoWare. I mean, there's a lot of components to it. So please send us your questions. We have engineers standing by to help answer your questions and help guide you through some of the ideas that you're trying to pursue. If you're installing CARMA and you need help and there's issues, please send issues through GitHub, through support services. We're here to help you. We want to make sure that you're not stuck with debugging issues. We want you to be stuck with solving the research problems. Try to solve that problem, and that's what we want to be able to help you and help you get started. So we're very excited about these 2 services, and thank you so much for your time today. We have also more areas for communication. We have the FHWA site, of course. We have more content going up on the FHWA site shortly. We have GitHub. You guys know where that is. Please go follow the GitHub site by going to the GitHub site and clicking the star in the upper corner. That way you'll be notified of all updates and code releases that come out. We're releasing code all the time, so it's easy for you to keep track of that way. Confluence, again, we're trying to make it easy for you to find the documents you're looking for, the design documents on, how do we write this module for ROS. We want to make that easy for you to find, and we also want to be able to interact with you all during the development of these tools using Confluence. So keep an eye on Confluence as we start to release more pages on Confluence with more content for easy access. And ROS Discourse, as we start to build out our technical working groups, we're going to be using ROS Discourse more on some of the ROS-related activities as we start to migrate to ROS 2. It's in our plans right now to migrate from ROS 1 to ROS 2. So we're looking forward to that journey with the ROS community as we move into that newer version of Kinetic. And so with that, as you can see in the chat pod, please, feel free to take some time to fill out the form. We want to hear from you. Where are you at this process? Are you identified as informative? You want to stay informed with CARMA? Do you want to be a user of CARMA? Are you a user of CARMA? And are you an accelerator? So we want to know from you where you guys are in this process so we can better assist you and help you in any way that you might have in pursuing this research, so we can learn about things you guys were doing, and together as a community we can learn together. So thank you so much for your time today, and with that I will pass this over to Monica.
So we would like to hear if you have any questions. You are available to use your audio, so if you had called in, if you had dialed in, we can go ahead and unmute yourself if you'd like and ask any questions. We also have, you see here, the questions and discussions pod available to you, so definitely feel free to ask any questions here and we can address them. I actually have some questions that we can get started with from our poll questions. But some quick notes you'll see here in some pods on the side. So you have the CARMA web links that we just displayed on the screen, so you can use those. We have, as well as today's presentation, available for download. So if you'd like to download that, you can, and we will also have this recording available through NOCO's site in the coming days. So I will actually pull up some of the questions I had from the poll questions. But again, if anyone wants to speak, feel free to go and do so if you have any questions, or type them in the chat pod. So I think I guess someone asked during the poll, will CARMA Streets be integrated with the CARMA simulator? Feel free to expand.
So I know that we have explored that option. We've looked at actually integrating many of the CARMA components with CARLA. But as Taylor mentioned, CARMA Streets being a new initiative and CARMA Collaborative also being a new initiative, we're really looking for guidance from our users as to what to prioritize for what would be most useful to them. Integrating CARMA Streets with CARLA is, like I said, something that we're looking at. 5G communication support is also something that we're looking at. I added in the cooperative perception system overview into the presentation because Taylor makes it clear over and over that's important to our community. And so, yeah, all of these things are considerations that we have for development of the architecture of CARMA Streets, but it is in a nascent phase, and the use cases that I presented are what's coming up next on our roadmap, and so we'd love to have feedback on exactly the sorts of questions that are being asked by our attendees for where to focus our attention.
Awesome, and I believe we just received a question in the chat pod as well, so there's a lot of conversation about automation readiness and what transportation agencies will need to do in response to vehicle automation. Can CARMA identify what agency may want versus need to leverage vehicle automation for improved transportation operations?
I think that's a very excellent question, and that's why we're investing this on the research side to answer that question. You know, what do we see as the opportunities in the future, and how we manage the system today, and how we could manage the system in the future with everything coming, with automation, with IoT, with all the different emerging technologies across our transportation environment, or business sector, right? So I think the opportunity that CARMA provides is the tools capable of addressing some scenarios that could help lead us to understanding what those benefits could be. What's the role of the future TMC in providing specific information to support or enable automation? And I think that's really where our focus is. And we hope to pursue that. We will pursue that within the CARMA program. But it's not only going to be us learning about this, it's going to be all the partners within the CARMA community across the country and across the world that are using these open source tools in many ways to understand how they could impact specific scenarios like work zones and incident management and transit, emergency vehicles. So I think that's a huge opportunity for us, and that's what we're trying to pursue.
Taylor? We're getting a lot of great feedback. Again, feel free to ask any questions that you may have in the chat pod. We have a few minutes that we can definitely answer those questions. And let me take some from the poll questions that we had earlier. Oh, we did just get a question from Brian. Has CARMA engaged other CAT-related TISMO groups to get a better idea of priority application?
That's a really good question, Brian. And yes, we are pursuing, all the different communities, the CAT Coalition, TISMO groups, with our Federal Highway TISMO program, with TISMO state groups and DOTs. And we're at that process of starting to, communicate what the technologies and get feedback from where they see it being beneficial to their program. And we are going to be publishing soon what we call the TISMO, I call the playbook, but it's really our high-level ConOps and our, that kind of helps us explain what are the use cases and where could this technology really benefit the TISMO community and agencies that are, managing the system within those program areas. And so that document we've been working on for, a little over a year, with agencies, I think over 50 agencies and organizations across the country that provided comments and feedback to it to help us, shape the priorities of where their agencies are and maybe what are the TISMO program areas we should start with, where we see, the greatest return on investment. So we are engaging with those communities, and we are continuing to engage, and that's the whole part of being collaborative. Is that we want to move this together with everybody's input and feedback, and that's what we're going to continue to do.
Awesome, thank you. And I think I have a question for Wade. So what's the timeline for the CARMA Streets release?
So we're looking at demonstrating those use cases that I presented in our A1 and Batista releases, which would be in the April timeframe of next year. Our release schedule has been delayed a bit by COVID, as you might expect, but that's our current plan.
Awesome. And just going back to that question that Taylor has, so when will that CONOPS document, Taylor, you mentioned, be available?
I don't have the exact date, but very soon. We're just going through the processes of finalizing the editing and all the requirements needed for 508 to ensure publication. So I think we're in good shape on the document coming out. We're just finalizing a lot of the editorial comments, but yeah, it's pretty soon. So we'll probably make an announcement, through social media and probably through the CARMA email list for those of you that have signed up to be collaborative members when that document does get released from us. So stay tuned. It's coming soon.
Another question. So what is the current level of cooperation with the MUTCDs?
So yeah, we have good cooperation with the MUTCD. They're a sister program within Federal Highway within our Office of Operations, and so we closely communicate with them. And so we will continue to, again, we are research, so we're not ready to be sentences and new chapters in that document. But I think as we continue to work together within our agency on, as we learn what the opportunities are of CDA, our research will be able to feed some good feedback to those decision makers.
And we have a question here from Brian as well. So any early success stories of collaboration for real world testing the CARMA Streets or other programs? In our case, other products.
So for CARMA Streets, I'll let Wade, comment on that since we're just kicking that off. We're looking for those partners today. But within the CARMA program, there's a lot of partners across the U.S. that have downloaded and are starting to use the software within different research efforts that they have. So through CARMA Collaborative, they've been engaging with us. They've been using support services to get feedback on how to, correctly deploy some of these tools and they've been providing a lot of feedback on where they see some bugs and issues, and that's the whole process of, doing pull requests, and submitting issues within GitHub. We're able to fix those, address those, and then push those fixes out for everybody. So there's a lot of success stories, I think, today, and there's more to come. I think that's what everyone here on the phone is attending because, we want you to be a success story. So look forward to seeing your work, Brian.
And like I've mentioned, so we have here linked in the chat pod the CARMA Collaborative Contribution Form, as well as the CARMA GitHub repository, so you can see more information about CARMA Cloud and the future release of CARMA Streets. We have a question that just came in from Joseph. In the actual or envisioned CDA environment, why not utilize the term of vehicle strings as opposed to platoons in describing behavior?
So that's a great question. And I think the way we've, kind of described these two behaviors between, let's just call strings and cooperative adaptive cruise control, and then when we say vehicle platooning, in some of the early work by some of the OEMs, they define cooperative adaptive cruise control as a string of vehicles that requires a level 1 automation. The way we define vehicle platooning within our program is more of a higher level of automation required to effectively do safe platooning, we don't want to have the human in the loop. So we're focused on more of an ADS level vehicle platoon where the system is in charge of maintaining the group, organizing, forming, and maintaining operations of that platoon. And so that's kind of how we define the difference between string of vehicles where you're just listening to some information and you have better insight to maintain your own independent safe gap following versus a formation controlled behavior of a leader-follower type paradigm.
Awesome. We also received a question from Mohammed about any open research awards to which universities or research faculty can submit. Do we have any an answer to that, any resources we can possibly provide?
Sorry, I had my phone on mute. See, it always happens during one meeting. We always say that. So yeah, I mean, there's a lot of opportunities. I think in the traditional ways we can pursue funding. DOT will have future opportunities. State DOTs, provide research funding for areas in this space. So there's a lot of opportunities there. NSF, DOE. So just keep an eye out for some of the notice to NOFAs that will come out over the next year, and those could be good opportunities that you could apply these tools to maybe a different problem. Maybe it's an energy problem, maybe it's a cybersecurity problem, or an AI/ML problem. So I think there's going to be a lot of opportunities across the agencies, both federally and state.
Thank you. I think we're getting, awesome, thank you. So we'll give it maybe another few seconds to see if anyone has any questions. Otherwise, I think we should be good to go, but we do, again, I'll give it a few more minutes, but definitely utilize this time to access any of the web links available in that pod on the top right. Download today's presentation on the bottom right as well. And like I mentioned, this is being recorded, so it will be available soon through the NOCO's website if you would like to share this webinar with any of your colleagues or rewatch it back. If you have any questions, I've posted the CARMA Collaborative Contribution Form that you can fill out, and you can also email karma@dot.gov if you want to continue today's conversation and get started with downloading CARMA Cloud on GitHub. Again, we have those free support services, CARMA support services, available to you as well to get you started. And otherwise, if we don't have any other questions, I think we can go ahead and end the webinar. I appreciate everyone being here and giving us some great feedback today. And I really appreciate the speakers for introducing some of the new CARMA products to our audience and really setting that up great for us. So thank you, everyone.